So good evening. So we are going to continue what we have studied last class. We have studied some of the problems in our related to
CC amplifiers.
CC amplifiers. Yes. So we have done the problems with related to the CC amplifier. So how many of you have finished the CC amplifier problems? How many of you finished this problem?
Finish,
So the problem was a common collector amplifier is constructed using an NPN bipolar transistor and a voltage divider biasing network. So the value of R1 is 56 kilo ohm, R2 68 kilo ohm, and the supply voltage is given 12 volts. Then you had to calculate the base voltage, collector voltage, and emitter voltage. Yes,
yes, sir.
and then emitter current as well. And the internal emitter resistance Re dash. What is internal emitter resistance or Re dash? Can anyone tell me?
Sir, 20.3 ohms. Sir.
No. I'm telling what do you mean by when I'm talking about the small notations of Re dash or internal emitter resistance. I have told you something which is it's something related to the supply, AC supply, DC supply, or something and all.
It denotes the AC configuration.
AC configuration of the particular thing. So here I am talking about the AC particular supply of AC voltage of the or AC resistance of that emitter resistor. Clear?
Yes,
And
sir.
then you have to calculate the
Voltage.
voltage gain. Voltage gain is nothing but the output voltage and input voltage. When a load resistance of 47 kilo ohm is used. Now, when I was talking about the common collector, so we have the load resistor as per with if I'll consider with respect to my C configuration or common emitter amplifier configuration, I was having the particular separate load resistor, but here I do not have any separate load resistor, which is so I will consider my resistor which is connected to the emitter will be considered as a load resistor. Clear? So this is from here we can find out what is the we'll just replace the value of load resistor in place of your RE. Clear? And from there you can find out the values. Now we'll just see the solutions. So what is the first thing you have done? You have found out the current. So this is the basic steps I shown you. So from there, those who have not understood or directly you can by using the Ohm's law. By using the Ohm's law, you can find out the base voltage. What is the base voltage you got? Please cross check your values whether you got the same value. 6.5 volt you got.
Yes, sir. 6.48 we got, correct, sir?
Yeah, 6.48. So the first decimal number digit, so you'll
Yes,
get
sir.
the 6.5 volt. What about the emitter base?
Emitter.
Biasing, emitter voltage. And then
5.78.
5.78. So it is nothing but 5.8 volt. Yes.
Yes, sir.
Then what is CE? Common the voltage common emitter configuration. If I want to take it, what it will be, VCC minus VE, it will be 6.2 volt. Okay, forget about that. So now emitter current, if I want to find out, can I find the emitter current? Sorry.
Yes, sir.
What is the emitter current you got?
1.23 milliamp.
1.23 milliampere. So and then AC emitter resistance. So AC emitter resistance, what I have to do? I have to use what? Voltage divided by current. But voltage, which voltage I have to use?
Silicon transistors.
Yes, the normal silicon transistor voltage, which is nothing but 25 millivolt by divided by IE. So here you have to remember that whenever it is nothing but AC emitter resistance, whenever it is AC parameters is asking, you have to talk about the AC parameters. So here, if I am talking about the AC resistance at the emitter terminal, I have to use the Ohm's law only. So am I using any other law? No,
sir.
I am using the basic Ohm's law, but what I am giving here, what is the voltage I am giving? 25 millivolts, which is nothing but a silicon voltage divided by IE. So you will get the what is the AC resistance, emitter resistance I will get at the emitter terminal. Yes?
Yes, sir.
So I get 20.3 ohms. Is it correct?
Yes, sir.
Now, now in this circuit, which is nothing but the common collector configuration, I was talking about the gain. So what was the gain formula? Gain formula is with respect to my AC and DC input signal. Yes.
Yes.
Or DC and input resistance. So I can find out AV is equal to V out by V in, which is nothing but IE into RE divided by IE, RE dash plus RE. Whereas this current and this current is nothing but what?
Emitter current.
What can you tell me what exactly specify?
Low.
There's some look at the notations. Look at the notations. See, when I was just we'll go back 1 second. Yeah. So here you can see that here I am using capital IE. Yes.
Yes, sir. Yes, sir.
So IE, what is the E I am using? It's a capital form, correct?
Yes, sir.
But what I am using here?
Sir, small current, sir.
So no, small current.
Internal.
What do you mean by I and small emitter? Small denotation, small denotation. Okay, so fine. Okay, if you have done this, what is the output? What is the gain voltage you got? What is the gain voltage? Anyone calculated gain voltage?
Sir, 652 volts. Will get.
Gain voltage, how you will get in volt? Gain voltage will be nothing, no unit. So I got AV is equal to RE divided by RE plus RE. So because I do not have any other terms, yes. So I got the 99.6% of the AV. I got 99.6% gain, which is very high gain, yes.
Yes, sir.
So from that I can make it out the gain of the amplification. So my signal, whichever I have produced as an input signal, it is giving me the highly gained amplified signal. Yes, that will be the conclusion I can make it out. That is the conclusion I can make it out. Yeah. So yes.
Sir, small RE dash means internal resistance. Sir,
internal resistance, but with respect to which signal? AC signal.
AC signal, sir.
Yes.
So small IE also, small E symbolizes current, AC current.
AC current.
Okay.
Which we are not finding, correct?
Yes, sir.
Which we are not finding. So that's why for gain, what I used something which I already have. Yes, so I have the emitter resistance and then AC resistance. Yes.
Yes, sir.
So with respect to that only, can find out the gain. So that's why in gain we had 3 formulas. We have different formulas. Yes. So here I will get cancelled. Yes.
Yes, sir.
So what I will left with? RE divided by RE dash plus RE. Yes. Agreed?
Agreed.
Yes. So hope the question is clear and everyone tried what exactly we have to do in this particular problem. Yes. Okay. Okay. Yes. So what was the last portion of this question? The last portion of this question is also draw the final circuit and corresponding characteristic curve with the load line. Now, whenever we have studied that whenever we draw the characteristic curve of CC amplifier or CE amplifier, we have certain points called the operating points, Q point, which is and then DC load line. There are 3 the characteristics. So whenever we have the graph, we place a line, slanted line, where your point or voltage is active. Wherever your point and voltage is active, that will be called as your Q point or operating point. Yes?
Yes, sir.
So that's what the circuit or the graph expected in this question as well. So now what about the circuit? Anyone has drawn the circuit?
Yes, sir.
How many of you drawn? Please raise your hand. Only 2 people. Okay. Okay. Great. Good. So we'll see what exactly the circuit is. Please. We know that the circuit of that individual, like the voltage divider portion of the base terminal, will remain
same, sir.
Yes, will remain same. Only what the circuit will remain same. Only what will change? The values are changing in that particular circuit, because now we have the values of R1, R2 and RE as well. Yes.
Yes, sir.
So I guess there is a this one is there. So it is nothing about 56 kilo ohm, 68 kilo ohm, and 56 kilo ohm, 68 kilo ohm, and 47